Hey class, it's Professor Bork. I wanted to touch base about a question I received from the Ask My Instructor feature. That is always a really good option, especially if you've tried a problem a few times and you're still feeling confused. So we're going to go ahead and walk this problem together. So this problem is from 2.2 homework. It's technically the sixth question down, so question number 6. But as you know, it's kind of difficult because right now, Pearson in the new edition does not have the questions numbered, which makes it a bit tricky. So what you'll see on your side is 2.29, which is the sixth question down. We're working on hopefully getting that fixed with Pearson, but in the meantime, here we are. So the question that I received was an experiment was conducted in which two six-sided dice were thrown 100 times. The sum of the pips shown on the dice was then recorded. So it sounds kind of complicated, but the pips are just like the dots. So they're saying they just rolled two die and then they counted them, right? And it says the frequency histogram to the right gives these results. Use the histogram to complete parts A through F. So A through F, that's a bit extensive there. So let's go ahead and get started. And you'll notice again, some of these problems are just like one part and some are multiple parts. So that can sometimes be part of the trickiness. One thing I also wanted to notice was when you are solving these problems, if there is a graph that's referenced, a lot of times it's easier if you can't see it very well, there is the option that looks like a square with the arrow pointing out of it that allows you to pop the graph out and it's a lot bigger. There's also often more numbers labeled. So that can be particularly helpful sometimes depending on how well you can see the graph. You can also zoom in, which does work as well. It just sometimes it sort of changes the formatting of the screen. So sometimes I do the pop out option more, but it's totally up to you. Okay, so the first question says, what was the most frequent outcome of the experiment? Okay, so this question, again, they give you the histogram already and we have to answer the question. So the most frequent outcome would be the bar represented here that is the highest, right? Because essentially they wrote all of them, rolled these die, and then they recorded how many times they had this sum of the dice, and then they made a histogram out of it. So we can see that like the highest bar here, that would be the most frequent, because again, this is just a frequency histogram. And it looks like it would be looks like the frequency is 20, but the actual outcome looks like it's 7. Right. And again, it's numbered between 6 and 8. It's centered right over there. If you want to pop it out again, you might be able to see it a little better, but the outcome would be the number between 6 and 8. So it'd be 7. Okay, so I hope that makes sense. Then the next one says, what was the least frequent? So again, you might be able to look at the graph and see that it looks like 2 is the smallest bar, the least frequent. But if you're having a hard time seeing it, you might want to pop it out and you can see a little better that, okay, 2 definitely has a frequency of 1. But getting 12 has a frequency of 2. So the frequency of 1 is the smaller part there. So what was the least frequent? They're saying what was the least frequent outcome. So we'll go ahead and put 2. Okay. Next question. How many times did we observe a sum of 11? So again, I'm going to pop it back out just so I can really make sure I see it. It has more numbers labeled here. It looks like 11 would be this bar here between 10 and 12. And it looks like, thanks to all these extra numbers labeled, it looks like it has a frequency. It sometimes takes me a while to like line up, but it looks like it's a frequency of 5. Especially when I'm looking for the y-axis label from these graphs all the way on the right-hand side, it's kind of like a far way to line it up. But yes, so it looks like this bar here at 11 has a height of 5. So that means that's how many times we observed in 11. So I'll go ahead and just put in 5. The next one, how many more sums of 5 were observed than sums of 10? So all just kind of different ways of asking you, like, look at the graph and sort of interpret the graph. This one actually wants us to find essentially how the frequency of getting the value to be 5, and then the frequency of getting 10, and then it says how many more. So essentially they're asking us to subtract them. Okay, so hopefully we can kind of see if we look at 5, that looks like it has a frequency of 10, right? And then we go to 10, and that looks like it has a frequency of 8. Okay, so then the question says again, how many more sums of 5 were observed than sums of 10? So how many more? It would be 2, right? Again, essentially there's looking for the difference. So there's just a lot of sort of vocabulary, a lot of reading and comprehending what the problem's really asking you to do, and for some of these problems, which I think can be sort of time consuming. And then says, what percentage of time a sum of 11 was observed? Okay, so let's talk about this. 11, it looks like if they just want to know like how many times, it would be 5. I think we figured that one out before. Yes. Okay. So it's 5. The thing is that's the frequency, not necessarily the like the relative frequency or the percent. So we would need to find the relative frequency. And so the way we do that is we just take the however many the frequency is for 11, which is 5, and we divide it by the total number of trials. However, it's kind of nice in this problem because it's 100. So you could turn it over to a decimal if you wanted to. That would be 0.05, but then they actually want you to write this as a percent, which is just 5. So it's kind of nice. And for these problems, when the trials are out of 100, essentially the frequency happens to also be the percent because it's out of 100. But that's just for this particular case, because out of 100. If it was any other trials, we would want to divide by the number of trials and then multiply by 100. Okay. But just because of it's out of 100, we can kind of sort of make that shortcut. So I hope that kind of makes sense. Okay. Let's see what we have for this last question here. I think we got to F almost. Yes. Okay. The last question is something that they kind of toss in at the end of this section. They start talking about shapes of the distribution. Okay, so there's 4 options here: skewed left, skewed right, uniform, and bell shape. So just to make sure, just a quick little blurb about each of these. Okay, skewed left happens when essentially there's a tail to the left. Okay, so if I was to draw, I'm drawing like a continuous curve, but like kind of the right idea. There would be like a tail coming off to the left-hand side. The tail is longer on the left-hand side. If you can kind of picture a tail, that's skewed left. Skewed right is the opposite, where there would be a tail to the right. Uniform is actually where they all have roughly the same chance, the same frequency. And so that would kind of look more like a rectangle. And finally, we have bell-shaped, which is, these are all kind of, we sort of roughly estimate. Bell shape would be mostly symmetric, right? And so I do think this graph, even though it's not exactly bell shaped, it's not exactly symmetrical, like essentially it's pretty close, but the 2 is a little smaller on the left-hand side, the frequency for 2 versus the frequency for 12, but like it's close enough, okay? So I'm gonna say bell shaped, because again, sometimes you kind of have to just like sort of squint a little bit and be like, okay, this looks more like this, even though it's not an exact fit. So that can sometimes be tricky. Okay, so I hope that was helpful. It went through a lot of different things here. It went through like, reading the graph, and then a couple of other sort of more difficult ones where they ask you to then read the graph and do something like subtract or turn it into a percent, and then also the shape. So again, this was 2.2. 2.29 is technically how they would label it, but it's actually the 6th question on your 2.2 homework, even though they don't have it labeled that way. Okay, so I hope this was helpful. Please keep me posted of any other questions you have. I'll be more than happy to make a quick video or just reply back to you depending on the question. Okay, thanks class.